My name is Rebecca. I am the chair for today's session. All right, so our first presenter this afternoon is Zack. Zack is the head of SCS at Checkmarx. He's armed with more than a decade worth of experience in cybersecurity, specializing in building advanced malware research systems. This talk will focus on sharing some of the TTPs that Checkmarx has seen and researched that can easily be used to fool developers into malicious packages. The TLP level for this talk is TLP clear, and there will be a Q&A at the end of the session. There are microphones available in the audience for folks to ask questions. As a quick reminder, please do remember to fill out a survey in the mobile app after attending this talk. And if you could kindly silence your devices, that'd be greatly appreciated. All right, without further ado.
Hi, guys. So, welcome, and glad to have you on my talk. As you said before, my name is Zack. I'm the head of software supply chain at Checkmarx, and I lead a team of researchers focusing around detecting supply chain attacks in open source packages. What does it mean? Basically, what my team does is that for every open source package that we monitor, and those just a small list of the open source repositories that we monitor, we download them and we run an analysis pipeline. So we are not looking for logical flows like missing validation or buffer overflow, but basically we are looking at things like the behavior analysis of the package. Is the package trying to touch your SSH keys? What do we know about the contributor reputation of the person who actually published that? Do we have any threat intelligence that correlate to that behavioral, both statically and dynamically? And basically, I have a team of threat analysts that every time that we find something suspicious, vets data results, what do we know about these packages, and basically we are tracking attackers in open source packages. The research that we produce, and we like to share our research, basically we write quite a lot of research, and I encourage you to go to our Medium website, where we discover new and interesting stuff every other day, and we publish those. I really believe in working together as a community. So we also founded a forum for supply chain attack research or researchers called SCAR. And there we share our findings and problems and frustration with other researchers in the industry. And I do encourage anyone listening to the talk and wants to be more involved to join this forum. It was inspired by an organization like FIRST, working together and sharing between people. So when I'm talking about open source, what do I mean? So there are multiple open source packages, and we all know that the open source ecosystem is blooming. We are seeing a lot of new open source packages being released monthly. NPM alone is more than, actually it's now close to 1 million new packages a month. And everybody uses open source, right? So you can do a lot of modern development without relying on open source. And developers want to deliver fast. And they use open source. But the problem is that many times when they use open source, they don't necessarily understand what they're doing. Let me give you an example. Developers look at the package seems legit, seems popular, seems okay. But inside an open source package, in many cases we have what we call a transitive package, meaning that open source package is actually using another open source package from a different contributor. And in many cases, it's not a one-to-one ratio, it's a one-to-many ratio. So for example, my developer wants to use an open source package called CNCGS. It looks legit, the developer seems okay, a nice guy, it's well maintained, but the truth is, this is what he's getting. So there is no way a developer, or even a security analyst, can really go and vet all of those sub-contributors and sub-packages. So understanding that, and developers understand that, we ask ourselves, why does developers blindly trust open source package? They are not looking at the code. So Talking with developers, we quickly realized that developers don't look at the code that they are using, but they are saying to themselves, oh, it's open. I don't have time to review the code, but if it's open, somebody else is reviewing it for me. If there is an issue, somebody else will notice. There is a scoring mechanism, so if it's popular, it must be good. And the really strong decision, everybody's doing that. So it's not just me, everybody's doing that, so it must be okay. And today I'm going to share with you what attackers are doing to abuse those assumptions. Before I get into the 5 techniques the attacker is doing, just wanted to share a couple of war stories that what we are seeing. When I started examining this field 2 years ago, it was really difficult to find malicious packages. Sadly, or happily, that have changed over the last year. The number of malicious packages that we are finding, and I'm not talking about logical flows, I'm talking about attacker deliberately poisoning open source package, have skyrocketed. And I want to share a couple of the stories that what we have seen this year, and then show you a couple of specifics, how they are spoofing the contributor and the reputation, so developers will actually download them. So we are seeing attackers evolving. What do I mean? So one of the incidents we were involved what we called a typo squatting. What does it mean? Some contributor, actually, some attacker upload a bunch of packages using a technique called typo squatting, meaning he said to himself, if the popular package is highly popular and I'll do a typo squatting, there's a good chance some developer will misspell it and will download the wrong package. Cool, quite normal. And then you look at the code and you think, oh, if something is bad, I'll look at the code and I'll find it. What we actually found is that the malicious code isn't inside the package. This is what we call a dropper. Basically, the code is reaching out to a GitHub repository and then downloading the rest of the code. Why GitHub? Any ideas? Easy, right? Any network defender will see traffic going outside to GitHub would surely authorize that, right? It's quite easy. Nobody will block GitHub. It seems legit. And he was going out and downloading a custom-made malware. We reverse engineered the malware, and we discovered that the malware didn't just use GitHub to drop the malicious file. It also used GitHub repo as a way to send command, as this C2 server. So we were able to see all the different commands being pushed into GitHub. And again, if you're the malware, you can understand what each command is doing. Understanding that, we found something which is interesting. We found that the attacker was afraid somebody will block his repo account in GitHub, his URL. So what is added inside the logic of the package is what we call DGA. And we've known DGA for many years, right? So this isn't DGA, it's UGA. So it's still GitHub, but he has a logic. If the original username is blocked, please try one of those usernames, which are, by the way, are still not registered. But if somebody will block his original username, it will just register a new one from the list, from the algorithm, and continue serving commands. So while inspecting that, we were actually, and report that on GitHub and gave him the full logic, we were actually able to see him giving commands to his newly created botnet. Again, because we reverse engineer the malware, we were able to see what he was trying to do. So understanding the logic of the malware, we quickly saw that he was targeting a Counter-Strike server. Everybody loves Counter-Strike. So what we did while waiting for it to be removed, we actually challenged him. So we opened an issue on GitHub, and we actually told him we're going to challenge you for a Counter-Strike tournament. Whoever wins, take the botnet. And of course, we were just laughing because a couple of minutes later, it was removed, or a couple of days later, GitHub removed that repository and everything. But it's very important to have fun, because the job is so tedious, so at least get some laughs. Another example that we saw this year, not just script kiddies, is somebody posting a bunch of packages, again, typo squatting. Looking at the code, we found something very interesting. The code, in this case, contained encoded code with using Chinese character. When the package was being run, it actually it actually created a malicious Chrome extension and registered that Chrome extension. What the Chrome extension does was actually looking at the clipboard, at every copy-paste action, and looking for those regex. Every time you do a copy-paste, does the copy-paste clipboard match one of those regex? Any ideas what those regex are meant for? Thank you very much. So let me show you in real life how it works. So this is like the Bitcoin wallet, and what I can do basically is just go to this website and copy-paste if I want to pay somebody with a Bitcoin wallet. And you can see that my Bitcoin wallet and the one that I copy-paste are the same address, right? But then I'm going to go now and activate the malicious Chrome extension. So it's there, it's registered. Again, for this demo, we're going to activate it. Going back, doing copy-paste. Can you see? It's not the same address. So basically, he was waiting for somebody to do a copy-paste, placing his attacker crypto wallet address, clicking the send, and you've lost your funds. So pretty cool. But the real story wasn't just catching these packages, understanding what it's doing, and removing them. The problem, it never stopped. What do I mean? So when we reported on the packages, we found a couple of hundred of those packages from the same attacker. We removed them. 4 days later, a new account on PyPy, new packages, removed them. Couple of days later, new account on PyPy, removed them. So we were getting nowhere. We were always cleaning after him. So we thought as cyber responders, is there something we can climb up in the pyramid of pain? Can we understand something about his logic so we can proactively block him? What we did notice is that every time he used a different PyPy account, but all of those accounts were prepared beforehand, and were prepared on a very specific date. So we understood he prepared all of those accounts, and every couple of days is using one of those accounts to publish a batch of malicious packages. So we know about a couple of those user accounts. Now what we can do, we can go and see where there are other still dummy accounts created on that day waiting to be used, so we can proactively block them, right? Getting one step ahead of the attacker. Sadly, it was difficult because there are a lot of users in PyPy, and you don't have an API to query that. So Tal, my head researchers, did a very clever thing. She said, how can we know about all of the users if we don't have an API and we don't want to crawl this entire website? So basically, PyPy website and other websites support what we call sitemap. So sitemap basically isn't related to security. It's a way for the Google search engine to effectively crawl your website. So every time a new page is being deployed into PyPy, PyPy stores it in a file called sitemap and offer it for the Google search engine. Because the username is part of the URL, we said, why not just take the sitemaps, put them inside the database, and now we have a full list of all the users and all the dates. So that way we were able to get the full user list. Up until this date, we got 15, 20, but we were able to proactively catch all the other user accounts and proactively stop his infrastructure. So again, we are seeing attackers getting involved, preparing infrastructure, getting more and more serious, and we are seeing all the normal techniques we see in malware now being used in open source malicious packages. For example, the WASP case. So we found a package, seems typo squatting, very popular. I'll show you how to spoof this popularity in a couple of minutes. And basically what he did, he downloaded a PNG file, an image. What can I do with an image? Exactly. Basically, you can store code inside that image. So this is the image. And basically, because nobody will block an image downloading to his computer, the package actually goes out, reads the image, and inside the image, there are additional code. And that code actually directs to a second site. And then that site, when you go to it and look at the code that you are getting, we actually saw this. On every call to that site, the code actually changed. They change encoding per call. So attackers are evolving. This is quite cute. Basically, in the end, all of this is an info stealer and is using what we call Discord as a C2. This is a trend that we are seeing, using Discord as a C2 as a highly popular or highly trending technique, using webhooks. And we were able to take over the Discord channel and remove the attacker. But we don't have a problem with malicious packages. It's not the problem. The problem are with attackers. So when we find a malicious package, and when I ask my threat hunters to look at that, what we are actually looking is that what do we know about the domain? What do we know about the email? Are there any other packages related to these malicious packages? I know this is malicious, but can we look at the actor? So when you start with a small package, you end up something like this. So this is, sorry. So I'll go back. It's running too fast. So basically, this is a whole map of hundreds of malicious packages. Some of them were reported by other companies, but nobody is taking the time to look at the attacker infrastructure and understand that behind those 10, 20 packages, there are a lot of other packages. Looking at that, we were able to track, I think it's a Brazilian threat actor group called Lofi Gang. They were actually active for a year, a community focused around poisoning supply chain packages. They have their own Discord channel. We look at the number of the members they have. Then they distributed how-to guides to poison malicious packages, their ideas. They have their video YouTube channel, so they're not really afraid of being caught. And when we joined the channel, we were able to see them like giving every new member a stolen credit card as a gift, and instruction about how to, when you're using their malware and you steal credit cards and things like that, how to sell them online. So we were able to track the online websites and just saw them selling all the stuff they got from this operation. By the way, we always say don't take code from strangers without vetting. Let me add to that. Don't take code from attackers without vetting, because we discovered in most of the tools they were giving other people to use, they also had a backdoor inside that tools. So if they're using their tools, they were actually infecting the newbie attackers using a small package they write. So we are seeing them, a lot of threat actor groups and communities and things like that. And we always want to understand what the attackers are doing is, so when I see a package targeted for a medical company, and we were able to detect that it's a medical company, and we were able to detect that this is something that we've seen over time, we got interested and we take the code, and again, we run the code. So when we are running the code, I was actually able to see all of the activity being sent out. So we told ourselves, we see like a basic shell. The attacker is opening a basic shell and running commands on the infected system. Can we reach out and talk with the attacker? So what we built a proxy that every time that he runs a command on the station, like ifconfig, instead of the result, we will replace the result with our message. Basically, you can think of it as an attacker Slack. So basically, what we did is we actually saw him like running commands using pickup, and then we'll probably share the code. We basically built a reverse proxy to inject our messages inside the C2. So he was running things like, who am I? And this is the result he got. Who are you? And basically, it was saying, ls, no, we didn't want him to run ls. So I said, no, let's talk, who are you? So we basically started talking with this attacker and got his input why he was doing that. He claimed he was a security engineer. We said security engineers doesn't drop shells on people. So again, you have to have some fun, right, guys? And then at some point, he got really afraid, and he was saying, no, it's not me. And basically, we saw in like a couple of minutes him removing all of the shell stuff from the package he published, because he realized somebody was monitoring him and trying to track him down. Again, this is just like one example. And the reason why all of those attacks are so successful is that attackers can quite easily spoof the popularity of open source packages. And as we said before, this is like the main criteria, should I use this open source package or not? So let me show you how easy it is to spoof all of those criteria, and then we can see all the attacks that I was showing you, right? So one of the first things that we noticed is that popular doesn't mean safe. Let me show you what do I mean. So the first method, and I said like 5 easy ways, there are actually 6. One is on the house, one is a bonus. So let's start with the first one, star jacking. So basically what you're seeing here is you're seeing a legitimate package, and as I said before, a typo squatting, a malicious one, right? You can notice that the name, Pumpy and Pumpy.io, is quite similar, right? So, okay, one of them is legit, the other isn't legit. If a developer will download the wrong package, wouldn't he notice? He's expecting a certain functionality. If I download the wrong package, wouldn't I instantly realize that something went wrong? What do you think? So the answer is sadly no, because both of the package contain the same code. But, and there's always a but, right? Pumpy.io, which is the malicious one, add a bit of extra code, another small dependency. And when the code is running, except of doing everything right, it actually adds this line of code. If you can see the first line of code, you see the -1. You can probably understand why the -1 is there, right? Everybody is doing capture the flag. It's actually a reverse URL. So when the package is running, all of the developer credential, SSH keys, is being sent to the computer attack. Okay, so we understand. Pumpy.io is bad, transitive, nobody's looking. I've already talked about that. So what's new? What's new is when we are telling developer to download packages, we encourage them, don't just download package. Look at the popularity, right? Popularity in packages isn't likes, it's stars. So we know that Pumpy.io is malicious. Pumpy is okay. What's wrong with this picture? Both packages have the same reputation. How was the attacker able to spoof the reputation of the package? So usually at the security conference, somebody will say, bots. He has built an army of bots to do likes. Easier than that. Let me show you. So it's really easy. So what you're seeing now is an internal system developed by my team called PackageLab. You can think on PackageLab as a metasploit for open source packages. So we're going to do a supply chain attack from the attacker point of view. So when you want to publish an open source package, all you need to do, first of all, is identity. You just need some kind of an email account. Like a Gmail account would be fine. You don't need anything beside that. So you have a Gmail account. Now you can publish every package that you want. Second thing that you need to do is what we call metadata. So you need to give it a name. In this example, I'm going to give it supply chain demo, but I could have given it like Pumpy.io free, Pumpy.io NG, right? Give it a version. So a tip here, if you want to fool developers, never use version 1. Always use like some version which is higher than version 1. And now comes the funny part. Now, I'm pushing this package into, in this example, Python code. So you can think on PyPy like an Apple store or an Android store. So PyPy doesn't know me. So basically, I'll need 2 more minutes. So basically what happens is that I'm gonna claim that I come from one kind of a GitHub repository. In this example, I'm gonna take I'm gonna take this repository, wait for it. What just happened? So when you claim that you work for a company in GitHub, PyPy will automatically copy the stars from that project. And I could have claimed Kubernetes. I could have claimed whatever, just get the stars. So that's the main metric developers are using to vet their packages. By the way, it's not a bug, it's a missing feature. So star jigging will allow me to do that. Now is the part that I'm actually writing the malicious code, and after that, the code will be deployed. We're a bit short of time, so I'm just rushing it forward, but I will leave you the slides, guys. And then we have what we call a dynamic loader, go to pastebin, read the code, execute the code. But in the end, a couple of minutes, and boom, can you see the stars? So first way to do it is just star jacking, right? It's that easy. The other thing is repo jacking. Repo jacking is a way for me to take over somebody else's original GitHub repo, where the code is stored. Basically, this technique is available because when a user changes his GitHub username, for example, I was Zack, I want now to use Zack1, GitHub allows you to do that, and actually, if somebody was using Zack package, it will be automatically redirected to Zack1 package. So GitHub actually helps you with that, and it provides you what we call an automatic redirect. So that's cool. Everybody was using Zack. Zack move, nothing breaked. Until an attacker can reclaim the name Zack, and then all the people who used to come to the old package will now be served by the attacker. So repo jacking is basically a way to hijack rename accounts that people are still using their references, and it's quite effective. And we found thousands of stars projects in GitHub which are easily hijackable, and then people will just come to you thinking that the redirect still works, and it doesn't work anymore. So that's quite problematic. Fake commits is one of my favorites. So looking at the contributor, I only want to work with somebody that is experienced, has reputation. I wouldn't work with this guy. I would work with this guy. So how does a developer gains reputation? Basically, when you do a commit, every commit you make, that's better for you. And in the commit, you have a timestamp, right? You have a date and an offer. The problem, those are free text. So I can do a commit now and claim this commit actually was in 2021, or in the future, or in the past. Nobody's checking. The offer of the commit, nobody's checking. I can be whatever I want to be. So that actually leads to things like when you're going into a project, then I'm looking at the contributor. The video isn't starting, right? Why do we do that? So what I can do is basically go to every developer on GitHub, and I have the script to share with you later, and saying I want to make him a senior developer. Basically, I'm now setting up commits with earlier dates. And my profile, which was empty a minute before, will now show that I'm a developer who's been working for years. So now I can go to GitHub, and this was the profile before, refresh it. Oh, I'm a very experienced developer. There's no problem working with me. The problem, I don't want to work with just one developer. I'm looking at other people contributing code to this project. No problem. What I can also do, basically, is fake contributors. So again, the same script, but this time I'm actually, what I'm doing is basically going to the project, see there are not a lot of people there, just me, going and do another commit, and I can use any of your GitHub usernames, and it will show like you are contributing code to my projects. Again, people don't understand that, don't trust what you see. they will see all of this and they think that's actually okay or legit. So again, add contributors, that's it. So it's very easy for developers to be fooled, by the way. So every metric that you see can be easily spoofed. So again, those is the add contributors. Now I've added a couple of fake contributors. One of those is actually the author of Trello, a very high profile, high trusted contributor. And as you can see, you can just take his username, add it to any GitHub commit, and it seems that he is contributing code to your repo. So it's quite easy to get his reputation. This is basically all you need to do. Just change the name, nobody's checking. That's it. So the other one is fake organization, and I have to finish right now. Basically, when you go into the organization and you see the name there of the organization, you can write whatever you want to. So if you see it's working from Google, it's working, nobody's checking, it's a free text. The really sad part is some of the organization, I'll try to show it to you, some of the organization actually verify their organization. Like if you write Google, when it will say Google there, it will say verified. Because Google is a verified account. It doesn't say work at verified, but when a developer will look there and will see guy is working at Google, it will have a verified sign next to it. But it's not the right verify if you think about it, right? It doesn't say that guy is working there, just Google is a real company, because it's a verified company. So those are the ways, and the bonus method just ask for somebody for access to his open source projects, and he will get that. You are now maintainer. So we've talked about star jacking and repo jacking and contributor activity and non-contributor and organization. Basically, we have seen all of those techniques being used again and again. Awareness is key. I encourage you to go and check all of the tools that we are publishing to allow developers to understand the problem. We are also releasing more open source tools to help developers analyze those packages. And that's about it. 5 easy ways to spoof contributor package reputation, and why is it a problem today. Hope you find this interesting. I'll be around later for questions because we are a bit short of time, right? 2 questions. I got 2 questions. Go ahead, if there are questions. Cool. I'm just that bad, to be honest. Nobody understood anything. So guys, thank you very much. It was a pleasure being here. I hope you learned something new, and see you later.